All right, this is the final final time you'll hear me talk today. This is the third video. Again, I apologize for all the videos. I just thought in my mind that it made sense to me to keep each of the parts separate. So I wanted to start the 7.3 partial fraction practice worksheet with you, which is on pages 23 and 24 in your packet. There are 6 problems on here, and those 6 problems are all different types of partial fractions. Some of them have quadratic factors, some of them have linear factors, some are a combination of the two. There are no improper fractions on this worksheet, so they're all proper fractions. But number 2 is definitely a tricky one. It's more involved than the others because the denominator has a power of 4, and it requires a little bit of extra work. So if you want to just write this on a separate piece of paper, you can. You don't have to, or if you know where that worksheet is because it's in your packet and you were just taking notes in your packet, you can take out page 23 and 24 in your packet. But I will say that this is definitely a little more involved problem, so either write small or just do it on a separate piece of paper. Or you can start it on the worksheet in the packet and then you might have to complete it on a separate piece of paper. So the first step is to factor the denominator. When we look at this denominator, we have 16x to the 4th minus 1. So when I think about factoring this one, I see that 16 is a perfect square, but it's x to the 4th, so it's going to have to be 4x squared, and then minus 1. And then I have 4x squared and plus 1. All right, well, that looks good and all, but except, it's not quite factored, because factoring it completely, looking at this first one, we still have a difference of perfect squares. A 4 is a perfect square with a 2x and a plus 1. And then I would have a 2x and a minus 1. And then we still have that 4x squared plus 1. So we have our 3 factors. It is completely factored. That plus 1, 4x squared plus 1 cannot be broken down any further. It's completely factored. Now we just need to take this and start writing our partial fractions. So when I write the partial fraction, I'm going to write the squared term first. So 4x squared plus 1. Because it's a quadratic, the top gets ax plus b. Looking at the second, I have a 2x plus 1. That's linear. I already used a and b, so we have to use a c. And then the third one is 2x minus 1. That's our third factor. And here we pull in a d. So we have 4 different variables. That means you're going to have 4 equations with 4 variables to solve for. Now, the second tricky part of this is all of the multiplying that you need to do. And I'm going to start you off so that you kind of see what we're working with. Remember, we need to take this entire denominator, or entire fraction, and multiply it by the least common denominator. The least common denominator is the completely factored form. So the first fraction has 4x squared plus 1. Well, that fraction is missing the 2x plus 1 and the 2x minus 1. The next fraction has 2x plus 1, but it's missing 4x squared plus 1, and it's missing 2x minus 1. The last fraction has a 2x minus 1, but it's missing the 4x squared plus 1, and it's also missing the 2x minus 1. So here's where you're going to have a lot of the multiplying, and I'm going to kind of write this down here for you. You're going to have an x on the left, and only an x. And then you're taking ax plus b, and you're multiplying that with 2x plus 1 and 2x minus 1. Well, 2x plus 1 times 2x minus 1 was that difference of 2 squares, 4x squared minus 1. And then you're taking a plus c, and you're multiplying it by 4x squared plus 1 and 2x minus 1. I'd suggest maybe multiplying the two expressions together these guys here first, and then just distributing the c through. The last part that we still have to multiply is d, and that gets multiplied by 4x squared plus 1 and 2x minus 1. Again, I suggest multiplying those back two together first and then distributing the d through. So you can see there's a lot of foiling involved here. Be careful with your foiling. There's a lot of easy mistakes that can be made. I will be posting this final solution and a lot of the other solutions tomorrow. And tomorrow we will also have some time to kind of answer questions and get things done. And tomorrow, when I say tomorrow, I'm really meaning this is going to be posted on Monday, April 6th. So Monday, April 6th, there'll be a Zoom session, 2 Zoom sessions for you to kind of log on to if you wish. And I will be going through questions and answers and whatever you need help with on Monday. Monday will be kind of like a review day for us. So if you have other questions, feel free to shoot me an email. Have a great day and weekend.